So in this video I am going to discuss about the activities of basically the tyrosinase enzyme and the catechol oxidase enzyme. So these two enzymes have similar kind of enzyme activity, though the substrate is different, and a similar kind of active sites also. So we will be discussing side by side. So let's discuss about the tyrosinase. Tyrosinase and catechol oxidase. Fine. So these two have similar kind of active site. So this contains two copper center, both are present in copper 1, and 3 N-histidine with each copper center. So these are all N-histidine moieties. N-histidine, histidine, and histidine. Again, all are histidines. Okay. So what is the role of this enzyme, the tyrosinase and catechol oxidase? So they basically show the enzymatic activities in two different substrates. Let's suppose this phenol, and tyrosinase, TYR means tyrosinase, so short form is TYR, and is TY basically, and this is CO, so this is TY. So the TY is acting over the phenol and it will give the hydroxylated product first. So this is bisphenol, bis hydroxylated benzene, and further oxidation of this moiety will give the corresponding quinone. So this is quinone and this is bisol. Okay, so this both reaction is catalyzed by the tyrosinase, but the last step is only catalyzed by catechol oxidase. So to differentiate in this between is that the tyrosinase basically catalyzes the whole reaction from phenol to quinone, but the catechol oxidase only catalyzes the reaction from catechol to quinone. So the substrate is different. For let's suppose for tyrosinase, the substrate is phenol, and for catechol oxidase, the name itself suggests that it basically oxidizes the catechol moiety. So the for catechol oxidase, so for the catechol oxidase, the substrate is catechol. So why that if the active site center is kind of similar, both are having copper 1, then why the role is different? So the role is different because of the rotation in copper to copper center. So in case of both the enzyme, first step is O2 activation, like hemocyanin. So O2 bridged in between these copper centers like this, eta to bridging. So this gets oxidized, right? So this is called the O2 activation. The first step of this, both of this enzyme, is the O2 activation of the active center. But what happens in the rotation in between? So in case of tyrosinase, this rotation is allowed. Tyrosinase, the rotation or movement is allowed. But in case of catechol oxidase, this movement is not allowed. CO, movement not allowed, because in the protein chain, there is bound protein chain around the active center. There is a thiourea part. Okay, so there is a thioether part, and that thioether part basically restricts restricts the movement. So as the movement is restrict, the phenol is no more the substrate for the catechol oxidase, and it will have to get the catechol in order to do the enzymic activity. So this is the reason the presence of the thioether part. Okay, so now let's discuss about the mechanism. So we will be discussing the side by side. So there is here is the tyrosinase activity, and here we will discuss the catechol oxidase. So for tyrosinase, there is two copper center in the active site, copper 1 and 3 N-histidine with each copper center. So this is copper A and copper B, and copper A, all of the action will be taking place in the copper A center only. Fine. Then our substrate, what is the substrate for tyrosinase? Phenol. So let's bring the phenol, and the first step is the O2 activation, so we have to bring the dioxygen moiety also. So after the O2 activation, the copper will be present at copper 2 like hemocyanin, and eta 2 bridging, N-histidine 3 N-histidine, N. Okay, and there is also another thing, that the substrate is coming, this is the phenol, and there is a bounded water molecule which plays an important role in this activity of tyrosinase. So this present in hydrogen bonded with glutamic acid and with the aspargine, ASN residue. And what happens after the increment in the oxidation, this center is getting electrophilic in nature. So the phenolic O will eventually attack this electrophilic center, and once it attacks the electrophilic center, it gets positive charge. So to remove that, it will simply leaves that H as the proton source, and it will eventually go up to that water molecule. So what we will get after this? After this we will be getting something like that, N-histidine copper 2 O, and copper B center is unaffected. This part is coordinated now with the phenol. Okay, so phenol and this one have the interaction with the H, which is bounded to the water molecule. Okay, so this will be the fate of that molecule, and after that what will happen? This O bond will cleave, and we will be getting something like this. So copper N-histidine copper 2, and this remains unaffected, the copper B part. This becomes OH after getting a proton from the water medium, and now this oxygen is bound from that phenol also. So here what is happening, the CH activation is occurring, that CH bond, and it is directly coordinated with the oxygen. So this moiety is becoming like a catechol part. Okay, and there is that water molecule present around this active site. So after that what will happen? We will be getting our product, that is the quinone. So the quinone and water molecule, this proton will attack this part, and this part will leave as the water molecule, and we will be getting our deoxyform back. Now in case of catechol oxidase, what is happening? So here is the active site, this should be copper 1 N-histidine N-histidine. here water molecule is bounded as a solvent molecule. Okay, the first step will be the incoming of substrate. Here the substrate is catechol itself along with O2 in order to do the O2 activation. So the copper will be in the cupric form and like this. Okay, so N histidine, N histidine, N histidine, N histidine. So now if in order to coordinate with the catechol, copper has to lose one coordination side, so this will not be there anymore, and the O part of the catechol will coordinate with that copper P. Okay, so like this one, so copper A and copper B, and again what will happen, we will be getting our desired product like this, and the fate of this compound will be N histidine, N histidine, copper 2 here also, all will be the N histidine now, and OH, hydroxide group, hydroxide bridging. After that another catechol will come like this with a proton source, and again it will coordinate with this copper, and to coordinate with this copper this has to cleave one N histidine part like the previous one, so this remains unaffected. Now these two are N histidine, and like this it will get coordinated with that copper center and hydroxide group, and eventually it will get oxidized to the quinone form itself and water molecule to get back our deoxy form. This is deoxy form. So this is the basic difference between the tyrosinase activity and the catechol oxidase activity.